Welcome back to DM Academy. Okay, so for today, we will study about the dot product of two vectors. Or this time, we will multiply vectors. Okay, so how do we find the dot product of two vectors? Okay, so let's say we have vector A. Let's say we have vector A is equal to A sub x I hat plus A sub y j hat plus A sub z k hat. And we have vector B is equal to B sub x I hat plus A sub y j hat plus A sub z k hat. We're in the A sub x, A sub y, A sub z, B sub x, and A sub y, and A sub z are just numerical values. Okay, to find the dot product of these vectors, A dot B is equal to A sub x, B sub x, plus A sub y, B sub y, plus A sub z, B sub z. Or the dot product of two vectors can be calculated also by AB cosine theta. Okay, wherein A is the magnitude of vector A. That is the magnitude of vector A, which is A is equal to the square root of A sub x square plus A sub y square plus A sub z square. And B is also the magnitude of the vector B, which is the magnitude of vector B is also equal to the square root of B sub x square plus B sub y square plus B sub z square. And the theta is the projection between vector A and vector B, which we can solve that theta by, from this formula, A dot B is equal to AB cosine theta, deriving that to theta, it gives you arc cosine. Sorry, this is the inverse cosine of A dot B divided by the product of the magnitude of vectors A and B. Okay, so to understand more about the dot product, let's have an example. Okay, let's say we have vector A is equal to 2i hat minus 3j hat plus 6k hat. And vector B is equal to I hat minus 4j hat minus 5k hat. Okay, let us solve the dot product of vector A and B and the projection, the theta, between vectors A and B. Okay, so A dot B first. A dot B is equal to, using this formula, A sub x B sub x, that is 2 times 1 plus negative 3 multiplied by negative 4 plus 6 multiply it to negative 5. Okay, so A dot B is equal to 2 times 1 is 2, negative 3 times negative 4, that is positive 12, so plus 12. 6 times negative 5, that is negative 30, so minus 30. Okay, A dot B is equal to negative 16. So 2 plus 12 is 14, minus 30, that is negative 16. Okay, so this is the value of A dot B. Okay, next we will solve also the projection between A and B, that is the theta. So to compute the theta, that is the theta is equal to the arc cosine of A dot B divided by A and B. We already solved the value of A dot B. This one, the A dot B, and that is equal to negative 16. But we do not have any value yet of the magnitude of A and B. So let us solve first the magnitude of A, which is equal to the square root of 2 square. That is the coefficient of I, plus the negative 3 plus, that is 6. Okay, 6 square. Okay, and this is equal to 2 square is 4, and 3 square is 9, 6 square is 36. So that is square root of 49, or that is 7. Okay, and the magnitude of B is equal to the square root of 1 square plus negative 4 square plus negative 5 square. Let's check. 1, negative 4, negative 5. Okay, so 1 square is 1 plus 4 square is 16. Okay, then negative 5 square is 25, so that is square root of 42. Right, 42. Okay, so now the projection, that is theta, is equal to the arc cosine of A dot B, that is negative 16, divided by A times B, that is 7, times the square root of 42. Okay, so theta is equal to that is 110.7. It's 110.7 degrees. Okay, so this is our theta. Okay, so using again this formula, A dot B is equal to A sub x, B sub x is plus A sub y, B sub y, plus A sub z, B sub z. We get that A dot B is equal to negative 16. So what if we will use this formula, A dot B is equal to AB cosine theta? Let's try. Let's try another formula. A dot B is equal to AB cosine theta. Okay, wherein A is again 7 times B, that is square root of 42. Then cosine of theta, 110.7 degrees. Okay, so it must be close or equal to negative 16. Let's try. Okay, that is equal to negative 16. So same answer. Using this formula. Okay, so again, to calculate the dot product of two vectors, that is equal to A dot B is equal to A sub x B sub x plus A sub y B sub y plus A sub z B sub z, and AB times cosine theta. See you on the next video. Thank you for watching.